Hello everyone. If a star converts all helium nuclei into oxygen nuclei, the energy released per oxygen nuclei is. So if you see, when two helium nuclei converts into one oxygen, you can see the mass of the helium nucleus is given here and the mass of the oxygen nucleus is this. So you can see the mass here is changed, right? Because the mass of the helium nucleus is this, right? So if I write the change in mass, right? So earlier it was, now it is. So you can see the change, right? So I will write the change in mass is equals to 0026 minus. Now we want the energy released per oxygen nucleus. So energy released will be per oxygen nucleus will be equals to change in mass times 931 mega electron volt. So we got the change in mass, just multiply it with the 931.5. So it will be equals to 0.011 into 931.5, that is equals to 10.24 mega electron volt, and this is the answer of this question. Simple. Thank you.
In this problem, we have given a nucleus with mass number 220 initially at rest emits an alpha particle. If the Q value of the reaction is 5.5 mega electron volt, calculate the kinetic energy of alpha particle. Okay, so we have a nucleus with mass number of 220 emits an alpha particle. Consider the new nucleus having is Y and forming alpha particle of mass number 4. So the mass number of Y will be 216. Now, according to question, we have given Q value is equals to 5.5 mega electron volt. Okay, and we have to find the kinetic energy of alpha particle. Now, according to when this nucleus X will emit an alpha particle, then due to conservation of linear momentum conservation of linear momentum, consider the mass of alpha particle is small m and velocity is small v, will be equals to mass of y is capital M and velocity is capital V. Okay, so from here velocity of y can be written as small m into v upon capital M. Okay, and we have given the mass number of alpha particle is 4 and mass number of y is 216. Now the q value can be given as q value can be given as equals to kinetic energy of alpha particle. Q value can be given as kinetic energy of alpha particle plus kinetic energy of nucleus Y. Okay, so this will be equals to half into small m into small v square plus half into capital M into capital V square. So from here this will be equals to half into small m into v square plus this will be equals to half into capital M. V can be given as small m into v upon capital M square. Okay, so this will be equals to half of mv square plus half of capital M into small m square into v square upon capital M square. So capital M will cancel one in the numerator side of capital M. So this will be half of mv square will be common. So this will be equals to 1 plus small m upon capital M. And this half of mv square will be again given as kinetic energy of alpha, multiply by 1 plus small m is given as 4 and capital M is given as 216 and Q value is given as 5.5 mega electron volt. Okay, so this is equals to 5.5 equals to kinetic energy of alpha particle, and this is equals to 220 upon 216. Okay, so from here the kinetic energy of alpha particle can be given as 5.5 into 216 upon 220 mega electron volt, and this will be equals to 5.4 mega electron volt. So this is the answer of this problem, 5.4 mega electron volt. 5.4, this is 5.4 mega electron volt. Okay, 5.4 mega electron volt. So let's check the option. So we have the option, so option B is the correct answer of this problem. Thank you.
Hello everyone. For uranium nucleus, how does its mass vary with the volume? So let us talk first about the radius of the nucleus of the uranium. So it will be varying with the mass number. It is atomic mass number. So here the R naught is constant and its value is 1.2 into 10 to the power minus 15, right? So we know it is 4 pi by 3 R cube is equals to volume. So if you see, it will be equals to this R cube, it will be equals to R naught cube, and A cube it is A cube into 1 by 3, it will be 1. So this will be the volume. And if you see here the mass relation, you have to find out, right, how the mass varies with the volume. So if I talk about the mass, so you can see here we got the mass number. So if you multiply like mass of one nucleon, right, so it will become total mass, right, so let's say I multiplied both sides with the mass of one nucleon, so then you can see it's the total mass, and it is directly proportional to, so this is the mass of nucleon, we multiplied both sides, then you can see the total mass is directly proportional to the volume, right, so you can see here A will be the correct option. Mass is proportional to the volume. Thank you.
Hello everyone. Binding energy per nucleons versus mass curve for nucleus is shown in the figure. W, X, Y and Z are four nuclei indicated on the curve. The process that would release energy is. So the question is asking us to find out that which process would release energy. To find the answer to the question, we need to find out the binding energy of the given nucleus. The binding energy for W, which can be represented by EW, the modulus of EW, which is the magnitude, is 120 into 7.5, and this comes out to be 900 mega electron volts. Similarly, EY magnitude comes out to be 30 into 8.5, which is equals to 255 mega electron volts. In the process, which will be W to 2Y, we can see that the energy that will be involved in this conversion can be figured out by using Q is equals to EW minus EY into 2. As you can see that there are two Y nuclei. Therefore, substituting the value of EW and EY, we can find out that Q is equals to 900 minus 255 into 2. And on calculating, the value of Q comes out to be 390 mega electron volts. Therefore, on calculation, we can say that in process W to 2Y energy is released. Thank you.